Hello, my name is Brian Corcoran. I'm one of the software development managers at JMP, and today I'm going to tell you about how to build a Python-based data connector in minutes. This is kind of an ambitious enterprise, so let's go ahead and get started here. And I'll be able to provide other materials for you as far as notes at the end. So data connectors, what are they? Well, essentially, they're just ways of connecting JMP to your data source, whether that's a traditional database or a REST endpoint, could be a flat file. Sometimes they're built into JMP. For instance, Snowflake and AspenTech are recent examples of those. Sometimes they work with third-party drivers like traditional ODBC drivers. Sometimes, like today, they work with Python packages. Our goal, though, with data connectors is to allow you to share these connectors with your colleagues, even if you're maybe on a Windows machine and they're on a Mac. But the biggest thing to take away from this is they can be built by you. And if you're feeling generous, you can share them on the JMP marketplace. So all of this is made possible by something we call the Python interface to query builder. This was introduced in JMP 19. What this is it is a JMP library and Python classes. And if you implement the right interfaces within that Python class, JMP will understand how to take your data and show it in the query builder dialogues. You'll then be able to use the query builder facilities, like to create where clauses, select statements, and things like that in JMP. And it'll appear seamlessly, much like a JMP built-in data source. This allows you to access data that JMP just does not have the resources and time to get to, and may be particular to your industry. And you're getting the functionality of Query Builder for free. So in this picture, essentially, we're going to be spending time in this talk on the add-in interface component. We will be using a Python library to help us with the data collection. So what are the components of a data connector? Well, first, a data connector is essentially a JMP add-in, and a JMP add-in is really just a zip file. So what are the contents of that zip file? Well, there are five main components here. One is an add-in definition file that just gives you the name of the add-in. One is a file called the add-in load, and this is a snippet of JSL that's going to install any dependencies, for instance, Python packages, that you need for your connector to work. The JMP.dc or data connector file is a unique identifier for your connector as well as the type of connector that it is. This PyProject file really just lists the dependencies that your connector has so the loader can put them in. Finally, and it doesn't have to be called myaddin.py, but there's a Python file that does the work of connecting to the interface and also connecting to the Python data source. So in this demo, we're going to open a format called netcdf. netcdf is a multi-dimensional table format. If you've ever used HDF5, it's similar to that. You'll have columns and rows of data, and then you can have multiple tables within a single file. So essentially stacked Z order of tables. NASA, the US Space Administration, often uses this for their satellite data for astronomical and climatological data. If you start Googling this, you'll find that there are two Python packages often referenced as far as opening netcdf. One's xarray and the other is netcdf4. We're going to be using netcdf4 in this demo. Xarray is actually more frequently mentioned, but in my experimentation with this, Xarray failed to open about half of the data sets, and in one case tried to allocate 80 gig of RAM for a very small file. So I lost confidence in that and went with the slightly harder to use netcdf4 package. So my hope is the takeaway from this demo is, while this is kind of an extreme example and we're trying to do this very quickly, you can often do this in a morning or an afternoon. Now, the marketplace has a template for you to get started, and we are actually going to use that template. It's a great example of how to build a data connector. Also, modern tools like AI code generators can help you along. In my particular case, I looked at acquiring NetCDF data, asking Copilot, Google Gemini, and ChatGPT. I ended up going with ChatGPT, um, but in discussing how to get started with a data connector, I would encourage you to think about this as two pieces of work. The first piece is get your Python code working with standalone data outside of JMP. Next, the second part is then worry about hooking up the interfaces for JMP to actually access that data. All right, and that's what we're going to do here. I'll also mention all the materials I'm showing you are going to be part of the conference materials, including the add-in, the Python code, any of the specifications you see. There'll also be some notes on development associated with this particular demo. So let's go ahead and get out of here. And our first step is going to be, we're going to bring up marketplace.jump.com. If you haven't been to the JMP Marketplace, I encourage you to do so. JMP Marketplace has extensions for all kinds of different things in JMP, utility functions, data connectors, you name it. In this particular instance, we're going to go and we're going to filter on data connectors. All right, I'm going to go down here and you can see some for commonly accessed data, but we're very much interested in this one, the Python data connector demo. Let's open that up. I don't have time to go through this in depth. I wish I did, but my colleague Neil Sikursky developed this demo really to teach people how to create data connectors in JMP. It has some great documentation here, including the Python interface to Query Builder, and a description of all of the contents of the add-in to explain it better to you. Neil's demo has 4 components to it, actually. It essentially opens files on disk, and it opens text files, JMP files, and also zip files and JSON files. In our particular case, we're going to use the folder example within this. What that does is it allows you to look at the contents of the folder and all the files underneath it, and then select a file and ask the connector to try to open it. All right? So one of our steps would be now download this onto your machine. The other step would be figure out what code you're going to need to actually use your Python data source to open the file. All right, in my case, I mentioned I had ChatGPT generate some code for me. And the code snippet that I ended up using was the Python code to dynamically populate a data frame from NetCDF forward data without Xarray. All right, so how did I arrive at that? Well, I told you when I tried Xarray, it didn't work so well, so I didn't want it to use that. Why do I want a data frame? Well, JMP knows how to change a data frame into a JMP data table object in one line of code. That's part of the functionality that's been built into JMP 18 and even made better in JMP 19. All right. Now, when I got ChatGPT to generate this code, I found that when I imported my sample data from NASA, some values are coming in as -9999 and -999. Turns out these are missing values, and that's the way that NetCDF represents those. However, DataFrame and JMP prefer to use NaN values. So I went back to ChatGPT and I asked it to substitute NaNs for that, and it modified the code block to do that. If you were to use this same query now, you wouldn't have to ask it to qualify those missing values because it's going to learn from, I'd like to think, my example, and it just does that automatically for you. All right, so before we actually hook up the interface to JMP, let's look at what's happening here. All right, so I put in these 2 dependencies, import statements for jump files, jump libraries, because we're going to need those later. But the rest of this is ChatGPT. It's asking for NumPy and pandas. Those are used to store numeric data in Python. It's accessing netcdf4, which is the package we've decided to open this data with. And OS and path lib are used just to look for files on disk and make sure they exist. In my particular case, I've put in some hard-coded paths to some sample files to try out. The rest of this is code that it generated. And what it's doing is this is the key point right here, is it's just providing the path to the file and opening that all in one line in that dataset command and importing it as a netcdf dataset object. It's then going to cycle through the variables within a particular table. It's going to populate NumPy Python arrays with each column. Here's where it substitutes in my missing values. It's going to make sure that we have a two-dimensional table, and then it's going to take that and it's going to take each array or column values and essentially populate a data frame with those values. All right, so that's what produces our data frame that we need. And here's why we need the jump library. We're going to say take that data frame and turn it into a jump data table. At this point, all we really need to do is return that data table to jump. All right, so this code is very much kind of standalone. All right. Now that we have our code ready to go, now we can hook it up to jump with Neil's example. All right, we've downloaded our Python data connector demo. Let's go ahead and we're going to look in where Neil's demo has been installed. On the Mac, this is in a folder called Library Application Support Jump Add-ins. I've included the Windows location for Windows users out there in the conference materials as well. It's very similar. All right, so what are we going to do? This is Neil's example. It's sitting right here in the add-ins folder. We're just going to copy it. All right. I'm going to put it in a working directory that I like to use, which is my Python directory. And I'm just going to paste that whole thing in there. All right. Let's look at what is in this directory. All right, here's our add-in definition file. All right. Let's go ahead and look at that. And I will make that bigger. All right, so really all that's in a definition file is this unique identifier, and I'm just going to substitute a new name called netcdf.connector or underscore connector. And yeah, I'm just going right over the top of Neil's code. That's why I created a copy. And then we just have a descriptor for this, and I'll say netcdf4 data connector. We're going to leave the minimum version for jump as 19 because that is the first version that has the Python interface to query builder, which we require for this. All right, so let's go ahead and we're going to save that out and close it. Oh, as part of this, why don't we provide a new name for our directory? I'm going to call everything netcdf connector. Okay. All right, this file add-in.jumpcast, well, that is a file that the add-in builder creates to put in menu extensions or additions. And we don't have any of those customizations to the menu bar, so we're just going to go ahead and remove that. We don't need it. Now let's look at our add-in loader. And I'll go ahead and open that in Xcode. Oh, didn't mean to open an Xcode. Actually, we're not going to do that. We're going to open that in just text editor. Okay. Make that bigger again. All right, so what is this? This is essentially a submitting to Python a snippet of JSL. And what it's going to do is it's going to look at a dependency file where we list our dependencies. It's going to take those dependencies, see if they're installed on disk. And if they're not, it's going to install them. So we can use most of this code right out of the box. We shouldn't even mess with it. But we are going to put in our unique identifier, netcdf connector. and also the directory to find that code, which also is named that, all right? Once I make those changes, we really don't need to do anything further to this file. Let's just go ahead and save it. All right, this installed to, this is a marker put down during the extension installation from the marketplace. We don't need that, we're gonna throw that out. All right, what's in data connectors? All right, here are our data connector definition files. I think I mentioned that Neil's example actually does like 4 things in one, and it has 3 definitions. We're not going to worry about the CSV opening, and we're not going to worry about the simple file opening. We're just going to throw those out. The folder one is the one we care about. That's the one we're going to look at the contents of the folder, present the files under that folder, and allow those to be opened in JMP. All right, so let's go ahead and take a look at that. All right, so all this is a single line, and it defines the type of connector, which is Python, the unique name, and we're going to change that to netcdf connector. All right, and then this final item is important. This is the name of the class that will implement the interface to Python, or query builder, excuse me. And we don't have to change this, but I'm going to change this just to make it more clear. We're going to have a netcdf connector, and we're going to remember that name when we make code changes. All right, so let's go ahead and save that. All right, now we're into this final directory, and we're going to rename that because remember we told our loader to look for a directory called netcdf connector. All right, here's this PyProject 2ML that we discussed earlier. I'm going to open that in Visual Studio Code. It has our unique identifier. We're going to change that to netcdf connector. You guessed it. All right, we'll change the author to me. But you know what? We're going to leave Neil's email in there. Let him deal with the problems I create. All right. So now there's one thing that we have to put in here that's not in this file. And I did a bit of a cheat here. I put this on a little text pad here, but this is an array to describe the dependencies or packages that this connector relies on. In our case, it's only the netcdf4 Python package. If you had more than one, you would just separate these by commas within this array, and each one would be loaded as necessary as part of the connection process. Now it's only going to be installed one time, so that's good news. All right, so we're just going to save this out and close it. All right, so we're moving along pretty well. What's in the source directory? This is the Python file that's going to do all the real work for us. I'm going to rename that. You guessed it, netcdf connector. And we're going to open that in Visual Studio Code. All right. All right, so let's go ahead and see what's going on here. All right. Now Neil's example, what it does is it essentially looks for files on disk, and then it takes that name and passes it back to JMP, assuming JMP knows how to open that file already. Really, the purpose of this demo is to show the interface, right? Well, we're going to add more to that because JMP does not know how to open netcdf data. All right, but we only need the one example. So let's go ahead and we're going to throw out some of these dependencies because we're going to put in our own. We're going to get rid of this example that just opens a single file. We're going to find out where that ends, and we're just going to delete it. And some of this verbiage. All right, an example with the works, which means everything. That's the one we're going to use, the folder connection example. We're going to find out where that ends here. And we're going to get everything below the comments for that one and also throw that away. All right. So now we're down to the essence of what we need. Let's go to our standalone Python code and make sure that all of our import statements are brought into this connector. Okay. All right, that's what we're going to need. I think we're good. All right, let's see what we need to actually implement here. All right, folder connector type. Do you remember that name? That's the one that we had in that Pi project 2ML file that says, or jump data connector file, excuse me. What is the interface we're going to implement? We named it netcdf connector. All right, let's go ahead and make sure there aren't any others that we need to replace. We'll say folder connector type. We're going to replace with netcdf connector type. There's only one other example. We will fix that up, well, in a comment, and we're done with that. Oh, got too many F's though. Okay, let's go back here. And what is this doing? All right, this derives from the jump data connector type, and what this class does is essentially defines what parameters our data connector needs to connect to our data source. Maybe that's username, password. Maybe in our case, it's just the starting folder on where to look for data. All right, so parameters are going to be surfaced in the data connector dialog will be defined here. And Neil's class essentially provides this template on how you do that. So we already have in here the name of a folder where we want to start looking for data. We're just going to leave that in there as one of our parameters. All right, this next parameter needs some explanation. Child folders or schemas. Query Builder essentially uses naming conventions that are around traditional databases, and that is schemas and tables. Schemas being containers of tables. Now, a similar concept for a flat file system, which is what we're looking at for our netcdf data, are folders and files. All right. But we can't change the names of the dialogues within JMP. We're actually hooking into those. So we're going to say we're going to just keep that, but we're going to use the concept child folder or schemas as true, meaning every time we run into a folder, we want to look in the contents of it. When would you not do this? Well, some data formats like TDMS or even netcdf, you might have a single file that has many, many tables and maybe channels or groups within those tables. Maybe you just want to look at a single file and then break out your exploration into those tables and groups within those tables. All right, so you could toggle between modes here. The limit to extension field, that's just going to be, do we want to filter on a file extension? Well, most netcdf data I've run into ends with .nc, so I'm going to keep that parameter in here, but it's optional. And finally, direct to open. Do we want to support the JSL open command? And if we do, what paths do we want to have it start with? We're not going to support JSL open as part of this demo. We just don't have time to worry about that right now. Okay. All right, folder connector. We're going to change first. Let's go ahead and change that before I forget about that to netcdf connector. All right, just two instances of that. What does folder connector do? Folder connector is the implementation of the jump data connector class. One of three classes we're changing the implementation to here. This one really just kind of initializes variables for the connector and says whether it's using schemas, folders, or not. All right. It also contains that JSL open function. I could just, since we're not using it, I could just throw this code away and return none here, but I'm just going to leave it because it's not going to be called. All right, so we're just going to leave this code pretty much intact and go to the next one, folder data source. All right, before I forget about that, let's change it to netcdf data source. All right, two instances of that. All right, what's going on with netcdf data source? This is the really important one. This defines the functions that we're absolutely going to have to implement to provide the information in JMP's Query Builder. There's some initialization of variables here. We're actually using all these variables because we want folders and path information. we're returning schemas. All right, so for a folder, all that means is what are the other folders within that folder? This code is just cycling through that and returning those directories as a list in a Python array. We can just leave that as is. Get tables, what are the files within that folder? Again, we can just leave that. It's going to cycle through the contents of the folder, and if we have an extension, it will filter on it here. Otherwise, it'll just provide a list of all the files. But we don't need to change any of that, which is great news. All right, finally, we get to open table, and this is where we're going to make our changes. Once we've selected a file or table to open, this function will be called. Now, Neil's code is already just taking the table name and the file, the folder name, and concatenating, putting them together into one string. And in Neil's case, he just passes it back to Jump because he's assuming Jump knows how to open this type of file already. All right. Well, it doesn't know how to open netcdf, so we're going to go ahead and we're going to just delete that. And this is where we put in our Python code. I'm going to go back here and we're going to just copy this. Okay. And right here, we will put that in. Now, if you've used Python before, you know that it's very dependent on the tab order. Essentially, Python uses tab position for scoping of variables, if statements, for loops, things like that. So we need to make sure that's correct. Otherwise, our code will not work. Now, it looks like it's unhappy about file path. I don't think that's been defined. Well, we already have a similar string here called path that provides the full path to our file. We're just going to change that name to one that ChatGPT was already using, and it's happy with that. So we can just use all of this code that we've already generated in the AI here, but we have to just make sure to return our data table after we've loaded it to Jump. All right. If we have a failure or can't find the file, we should return none. And that is all. We're just going to save that out and we're going to close that. All right. How do we create a connector now that we have all the pieces together? We're going to go to the main directory with our subdirectories and our code, and we're just going to select compress. And there's a similar function on Windows. It's going to create this zip file. We're just going to rename that. We're going to rename it netcdf connector.jump add-in. And yes, we do want to change it to jump add-in because that's Jump understands how to install it. And when it sees these definition and loading files, it will know how to install the pieces that we need to make this operate. All right. So now let's go in to Jump 19. All right. So I've opened this a few times before, so it's in my recent list. I'm just going to go ahead and say, go ahead and open that file. It's going to say, do you want to install this connector? And it's there's an option for checking for updates. I'm just going to not worry about that right now. And it's going to crank away for a little while. All right, we can view our log and make sure that, yes, we successfully installed our netcdf connector. All right. I like to go ahead and restart Jump at this point. It's not absolutely necessary, but I like to make sure that the connector is completely written to disk. And now we can use it. Let's go ahead and say we're going to go ahead and connect to data connectors. All right, I'm going to say new connection. This may take a little while on my machine. I apologize for this, but I have probably over 20 ODBC-based data sources, and Jump actually checks to make sure that we can actually connect to all of those when it starts up. We're kind of changing that behavior in the future, but I have a lot of connectors. If you don't have this many, it's not going to take long. All right, so there is our netcdf connector. Now, one thing that's good to remember about data connectors is these initial ones are templates, and we still have to specify the information to connect. So let's create a template, a data connector based on this template. All right. So child folders or schemas, we want that. We want to look inside folders for files. All right. Our folder has a starting value. I have some data here, and let's go ahead and I'm going to go to new Finder window, documents, and we're going to look for test data. And I'm just going to copy that as a path name and put it in as a parameter. All right. And then I am going to say I have an extension that I want to look for, .nc. You don't have to do that one. Let's go ahead and test it. Make sure it found that folder to start with. It did. So I'm going to save my connector as netcdf demo. All right. Now I'll just connect. All right. And so this is the same query builder interface you would get with any connector within JMP. If I go here and I look in Excel, there's nothing here because I'm filtering on .nc. If I look at netcdf, well, there's some data. Let's go ahead and open this one in Query Builder. All right, this is our standard Query Builder interface. I can't remember exactly what kind of data this is. I think this is mineralogical studies from planetary data, but let's go ahead and build a query with that. I'm just going to add these first 6 minerals here. All right, so a lot of sparse data in this one. I'm going to drag calcite over to the filters. I happen to know from looking at this before, it starts around 0.2 for values. I'm going to say, let's only give the values where calcite's greater than 0.3. All right, so there's some of our data starts showing up. All right, let's go ahead and run our query. All right, so we end up with 4,000 observations of our 6 minerals we've selected. If I look at the source script that Query Builder has created for us, you'll see that it has our connector in there, our SQL select statement, and our where clause for calcite. If I wanted to, I could run this all over again to recreate this analysis. All right. Now, also, Open Table is available to you back here. If you do this, it'll just open the file directly. You see we have 150,000 plus observations of 36 columns of data. It is indeed very sparse in this case, but if we start going through here, it'll start appearing. Or we can just open a more populated example here, but you'll see that it's quite quick in its performance and it's going all through that Python code very quickly. So I thought that performance on this was quite good. All right, so at this point, we have our hook into Query Builder. You know, in this amount of time, we have assembled from Neil's marketplace example the pieces we need to hook into JMP and populate it with a data format JMP previously knew nothing about. If we wanted to share that JMP add-in file with our colleagues, we could. If we wanted to put it on the marketplace, we could submit it for publication there. All right, so hopefully this has encouraged you that it is possible for you to do this and open up a world of possibilities within your industry for opening, file formats that JMP has not had time to address themselves. As I mentioned, all the conference materials contain this add-in, contains a Word document with notes on this development. It contains the query for ChatGPT and also the Python code that I use for standalone access to the files to test out that code. So hopefully all of this will help you out in your development of your data connector for your organization. Thank you very much.